So I guess I have about an hour, and appreciate it. I'm really glad everybody came tonight. I really want to thank Eric and others for organizing Big Data Week this week and participating in Big Data Week. I think it's been really significant. As I was mentioning earlier, an email came into the university yesterday from Hewlett Packard. I saw it, I flagged it, I called the guy immediately. He had no idea. And we introduced him to the whole team, the Big Data Alliance, which has representatives from the university, from business, as well as government, and he wants to come down and have a lunch and participate. And you might have seen the article in Slashdot, which really wasn't an article, it was just a simple little blurb, a little blog posting about, is Montana the next big data hub? You know, people are starting to get it, and we're starting to create a signal-to-noise ratio that might penetrate some of the some of the ambiguity out there. And I'm here on behalf of my company, GCS, to talk a little bit about big data, as well as some applications that we are involved in or have been involved in. So I've been shifting a lot of my presentations on big data in the last couple of years here in this town, really more and more away from theoretics and sort of, I don't know, loose descriptions of this phenomena, to trying to show as relatively concrete examples as I can. So when I was asked to present tonight and write an abstract, I tried to focus on that. So we've got a standard defense one that I'll share, and you all have to be secret, never can leave the building stuff. And then, and that's where we really cut a lot of our teeth, and you've read about all that in the papers, but I'm going to give you a little bit of an idea where that's going now, to the extent I can. And that was really, really fun, and that's where we learned a lot. And then I'm going to talk a little bit about some land management applications that are kind of classically geographic information systems. I've been arguing for a long time that one of the reasons I think Missoula can make a play as being an international hub in big data is that we've got a university that for many years has specialized in understanding and how to manage and analyze a lot of data. Specifically data that is, has a real fundamental spatial component to it. We've got a lot of expertise. I'm in that tradition. I came out of the university in that tradition. And we've got experts across government, academia, and university that are understanding that. You combine that with sensors and how we're measuring and mapping and listening to the world, and I think you've got a perfect storm when it comes to claims about Missoula being a leader, not the leader, but a leader in aspects of big data. I didn't make that claim 4 or 5 years ago when I started doing this just thinking that we were going to fail. I actually thought about it pretty carefully, and I figured out what we could do together. So I'm going to talk about that, and then I'm going to show an example actually in healthcare that we're doing and we're working on pretty closely at our company GCS. So I also want you guys to feel free to stop me at any time. If you have any questions or comments, maybe questions, I don't necessarily need open-ended editorialization on what I'm saying at the beginning of my thing. But if you got questions, please just raise your hand, and I would prefer to have some type of dialogue here. I can talk for hours and hours and then some, as long as I have sugar and water. And so I do want you to stop me. If you hear anything or think anything, or there's something that jogs your thoughts. Essentially, I also would just like to start by quickly asking, because there's been a lot of emphasis this week on trying to come up with a basic, tangible definition of what this term means. I think Eric came up with a great definition in your presentation, or your introductions to presentations Tuesday. What's today? Wednesday? Thursday? Yeah, and I thought that was very practical. But what I would like is, if maybe I'll go around, if anybody wants to venture what they think this term means. That would be a good starting point for my talk tonight. So Eric, you've got it in the ringer. Does anybody want to raise their hand and venture a basic operating definition of big data? And there's no test, everybody can be free, and there's no dumb answers. It's all good. Yes?
Well, for the carriers, I think it's just a process of trying to stay ahead of demand and not get behind the demand curve, which has been traditionally a problem for us carriers as the internet has started, exploded, continuing to explode. It's very difficult sometimes to try to, get ahead of that kind of accelerating data demand that we experience.
Right, so for you it is about the pipe, it is about managing voice and data and content.
Having big enough pipes, affording the conduits to the big data centers that we need to be at to be able to enable you to do what you do in a place like this.
Yeah. So that's key. We'll talk a little bit about volume and explosion of data. I'm not going to throw out a lot of statistics on it. There is a thing called Google, and you can figure all this stuff out on your own. Anybody else have another dimension of big data or something, an operating definition? Yeah, Tom.
Well, my example would be that my dad worked on a translation program and he worked for Control Data to move text to sound for sight impaired people, and they didn't really get anything that was marketable. IBM and other companies tried to do a translation program from one language to another written during the 80s, and their result was, well, they shelved it, basically. And then Google was able to come up with something that is 96% effective in translating, even across multiple languages, such as Mandarin and Catalan, with English in the middle. The difference, I think, is that, or as I understand it, is big data is having enough volume of data that the messiness is overcome, and it lends a whole new perspective because of the sheer volume or the sheer altitude that you gain in the overview.
Okay, so you remind me of our guest speaker at the university had, Dan Wagner, a couple months ago. We brought in the guy that crunched all the numbers for Obama and did some pretty profound work. He had an insight that I kind of stuck with me, and he said, for the first time in human history, data is presenting itself in volume and form and structure in a way that it's now possible for us to glean more insights from. So there's kind of a perfect storm between computational power, the data itself, and maybe quote-unquote analytics. And we're now not prohibited from looking into it to try to gain more quote-unquote insight or understanding. So that kind of speaks to what you said. Let me get one more from somebody and what they think big data means, please.
Well, the only thing we're really missing is storage, where we put all this data.
Yeah.
The cloud is where it seems to be going, but it's also on our servers in our offices.
Yeah, storage is a huge issue. I think Sony 2 days ago announced a new tape drive that stores 168 terabytes, a tape. It's a world record. They're really happy to bring it out. It's phenomenal. 160 something, 175 terabytes a tape. Who's familiar with the project in Salt Lake City with a 3-letter organization you may or may not have read about in the paper every single day that prefers not to be written about every single day? You have any idea how much is being stored in there? So these are zettascale class operations. Exabyte is not adequate anymore. We're into zettascale class storage. And the problem with that whole thing, does anybody know what the end game is for big data on the planet Earth? Does anybody tell me? What's the end game here? Power. Energy. There isn't enough energy to maintain, store all the data that we are creating. So the biggest driver right now at the end of the day when it comes to this phenomena, in terms of some aspects of the phenomena, is just simply power generation. So why would that organization choose to site their facility there? Does anybody know?
Solar.
BPA, coal or something?
Think cheap energy, think power grid, and think cheapest electrons. What's the cheapest electrons available on the market right now? In terms of, well, coal. You can negotiate even cheaper rates if you're in good contracts with the Bonneville Power Administration in terms of hydroelectric. So the best data center guys I know, and this is not a cock about data centers, I'm not reducing data centers to big data, 2 cents a kilowatt hour is really, really cheap. So if you have a data center now in Arizona versus a data center in Montana, what's ultimately going to be cheaper?
Montana, probably.
And why?
hydro.
Well, hydro, but also, are we cooler here on average than Phoenix? So there's all sorts of weird things going on that I'm interested in, but again, I'm going to try to show some examples, not of that, but it just ends up opening up a really interesting conversation about where we're going as a society. And for those of you who don't know, big data was a term developed by Gartner. Okay, so there was a marketing technical expert at Gartner Corporation about 9 years ago who decided to coin the term. And we are actually at the downward side, the downward trend on big data and the hype cycle. So for those of you that read Gartner, I'm not a Gartner expert, but someone figured out how to put a term on this thing, this convergence of data and volume and velocity, and they called it big data. And the guy is very, very defensive as a term, and I argue with him about once a month about articles I write, and I don't give him credit for the term, and he goes around trying to police the fact that I wrote that, that's my term, and you know, fine, I'm glad you invented a buggy whip, but you know, good luck. And but it was Gartner that really did this, and the way they look at this is that nationally and internationally, the hype cycle in big data kind of crescendoed about a year and a half ago. So now people are looking at the next big hype cycle. It's not big data anymore. But as you know, Montana generally is late to the game, and then we ramp, we're sort of late into things. We're kind of behind the zeitgeist in many ways. It's not bad or good, it's just what it is. And so all I was doing as an evangelist was going out into the world, coming back, and we were saying, and really I have to give credit to Eric. When we launched the first class, A class at the University of Montana in a type of analytics associated with quote unquote big data phenomena, it was Eric Tangendahl who stood up and actually taught that class. And now, as a key partner in this effort, I think in Missoula, the university is really, and I'll keep arguing this publicly and privately, we really are looking to the university to continue to lead the way. Nancy, Belva, Eric's father, et cetera, et cetera. We really need the university to lead the way. That is the single biggest discriminating factor to our advantage if we're trying to create a hub when it comes to big data analytics in Missoula. So anyway, that's my soapbox. GCS is a geoanalytics company. We provide interdisciplinary systems for land defense and health. Now that's a relatively brand new articulation of who we are. We've been around a long time, at least for Missoula, 13 years, going into our 14th. That company was essentially conceived at University of Montana. And myself and a couple friends started it. And the big difference about that statement right now for us is that generally we are a company owned and managed by technologists for technologists. And that's a bad idea. We have gotten to where we are through just tremendous hard work and a lot of determination and a good client base locally, blah, 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 nationally and internationally. But it dawned on me, and I went to raise some more money from a private equity firm here in town about 4 months ago, and they have $150 million on the sidelines, and they said, Alex, what do you do? And I went into my technobabble, blah, 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 and they said, Alex, we don't have any idea what you're saying. Stop. You eat your own dog food, you clearly don't know how to communicate, and I consider myself a pretty good communicator, and my friend was kind, but the two other guys aren't kind. They're like, look, we're not going to invest anything, and you can tell us what you sell, who you sell it to, and for how much. So we had a big radical meeting at the company, and we decided to start talking about the industries we're in versus the technologies we use every day. That's a huge difference for us, and I'm really proud to share it, because you guys are the first to hear this publicly. Focusing, which is a really difficult word for me to say, on land, defense, and health. So, again, I'm going to go through these pretty quick. We deliver analytical solutions. A lot of our bread and butter involves taking data of various types and various sizes and dimensions at various rates, as we all know, and building that into some type of business process optimization toolkit, which is a fancy way of saying we build things for people. We build really big things and we build really small things. Back in 2004, we wrote the original code for Google Street View. We made very little money on that. I wish I'd known more about business at the time, but someone came to us and said, build this, and we did, and we sold it, and then 3 orders later, that was sold for $390 million bucks. But we figured it out. So we're more interested at our company, at least historically, in figuring things out than we are how to make money. And that's not great if you're trying to build a business, but we pride ourselves on that. The reason we use the computer screen is probably 80% of our clients, we put all this stuff into a browser. We end up putting it on a phone, we put it on a browser, and people want to access our information. So, but our main philosophy is you can't do big data into workable things unless you understand the entire system of systems architecture, right? So we're constantly trying to look at what's going on that's novel in terms of data, data storage, data techniques. What's going on in terms of the pipes that connect us? Where's the network? And then ultimately, as you guys know, about every 39 seconds, something is changing at the presentation layer about how all this stuff gets to people. So it's a really interesting, brutal taboo of change, continuous change that we're facing in the industries. And unlike a lot of companies, we don't make a particular thing and sell it 100 million times. We build a couple Ferraris every year, a couple Fords, and a couple Yugos. And Ferraris meaning high-end, $1.5 million engagements. Fords meaning $500,000 to $600,000 engagements, and then the Yugos are 50,000 less. And I shouldn't say that because I think Yugos are great. Do they even make Yugos anymore? I think from Yugoslavia or something, but maybe the Soviets have taken them back.
It doesn't exist anymore.
Oh, it doesn't exist anymore? So who can tell me, can anybody tell me what that algorithm is right there? Who's a good math person in here? Or physicist? This is okay, well that's a Fourier transform. This is a clustering algorithm. This is an algorithm we wrote for a client that basically tells you when there's going to be an earthquake and how that earthquake's going to impact a property. This is another version of clustering, very spatial. This is a network diagram. This is an example on the Internet of Things. And this is a Markov chain. So we take all that stuff, which is more or less complicated, and we turn it into this. Because people have a really hard time working with those calculations and algorithms. My math skills are pathetic, and we try to take a majority of those functions, we put them on servers, and we deliver answers to people in some consumable way. So we have a major play in visualization. And the reason we call ourselves a communication company versus an information company is I'm convinced, and I continue to be, as more and more noise is created, more and more data is created, that you have to be able to separate the wheat from the chaff and get what is so-called actionable, or the core insights, or the meaningful information to people. You know, if I build something for a client and I just give them all the data, that is absolutely worthless. What they're asking for is, okay, we got all the data, but what are we doing to extract, again, meaningful, actionable intelligence from that? And I don't care if you're a warfighter, or you're a CEO of a Fortune 500 company, or you're an emergency room doctor, or whatever. There's a common denominator here of, there's a lot of stuff out there, but I don't want 45 million videos. I want the one video that captures what I'm looking for. So that problem, by the way, guys, is going to get worse before it gets better. So we do a lot of that. Now, I already talked and alluded to where the marketing has gone on this. These infographics are, I mean, there's hundreds a day that are created in the space. So you had the early adopters in terms of the hype cycle, and then it kind of washes through the rest, and people are trying to figure out, what do I need to buy? What do I need to buy? What do I need to buy? And people are buying a lot of stuff right now, but actually not many people are using it effectively. So there's a lot of purchasing of servers and software and technology and broadband pipes and this and that, but people have not begun to, according to the data I read, begun to realize the ROI of those investments. That's at least what I'm seeing. But this slide gives you some examples. 40 zettabytes of data will be created by 2020, an increase of 300 times from 2005. So we're into information of volume that's ridiculous. In the velocity, a terabyte of trade information every day on the markets. The average car has 100 sensors in it. That's actually conservative. Your average phone now has 15 embedded sensors in it. There's 6 billion phones on the planet. There's 7 billion people. There's going to be about 8 to 9 billion phones. The variety, the big area that's really got us really stuck right now is so-called unstructured data. Who knows databases in here? You teach databases. When I learned databases, kinda, at least a little bit from Hans, and databases are neat. We love them. They're good. They're great. But the relational database management system is being challenged by what? Unstructured data. What is most of the traffic going across your pipes right now? What's the most of the traffic?
Video.
Video. Everybody's taking video of everything. Everybody runs around now taking video of everything. I don't understand why we do this, but it's happening. My daughter, who's 15, 16 years old, all she does is video and Instagram and face chat and tweet chat and Snapchat. And I'm just like, I don't understand, but the culture is exploding. And each one of these kids have devices. And I guarantee you that's how they're communicating and learning. So YouTube, right? You want to talk about people that figured out how that? So you got a lot of that. And then the veracity, this is often misunderstood, the 4 V's of big data. Who thinks about here about authenticity of data? Where data come from? Who creates it? Who manages it? Now we've read a lot about what you can do to manipulate data and the fact that, hate to tell you, but you really don't have any privacy. So figure out what you want to do constitutionally there, but that's gone if you really think about it. But the statistic here is, I thought was amazing. 27% of respondents in one survey were unsure of how much their data was, how accurate their data was. Now those of us in the GIS community, we got beat into our heads. Who creates it? Who creates it? Where did it come from? What's the accuracy? What's the standard? But I guarantee you there's no standards governing the explosion of the information that we're creating right now. It's so easy to create it and share it. Who knows where it comes from? You get where I'm going with that? So this is the notion of veracity, and that's authenticity, and that gets into metadata. My one summary about here is the big area that most people are not focusing on, whether it's in the semantics area or the ontologies or the epistemologies that we're dealing with when it comes to information science and information management, they are not dealing with metadata and a successful, scalable metadata application in order to understand where this information is, where it's going, and who created it. It's very, very troubling. I've already shared this. GCS likes to place ourselves in the middle of those 4 circles. Very difficult to do. I'm going to go through that quickly. As I was mentioning earlier, about a year ago, let me put it this way. The cloud has been building in terms of infrastructure as a service and what you can achieve. When Dan Wagner from Civis Analytics and many other people talked about, for the first time in human history, it is now possible with, I think Eric said it very well last night or the other night, with the cost of a credit card, maybe $2,000 to $3,000, you can spin up instances of Amazon Web Services and be in business and have a company off and running. And by the way, if you've got volume, you've got clients, and you can scale that now into some very significant data services and data servers. So the cloud is an interesting phenomenon. And I think people need to understand that. Number 2, and by the way, I'll argue that it's very hard to keep up with the market conditions associated with cloud because, as we all know, was that Amazon's primary business plan to be a cloud company? No. The guys at Amazon figured out that they had a bunch of excess or idle what? Servers. CPUs sitting around not selling dog food to people. So they said, you know what? We can make money on all that excess heat that we're generating right now, and we'll open that up into a VM environment, and wow, game on, right? Okay, mobility. Who has a mobile phone? Does anybody in this room not have a mobile phone? You don't have a mobile phone?
I've got one that you can talk to, not one that you look at.
Okay, but you have a mobile phone.
Yeah.
Yeah, so there's no one in this room that doesn't carry a mobile phone, right? How many people, just out of curiosity, how many people are using tablets or some type of device in their daily activities? Raise your hands a little higher. I can't see anything. Okay, so that's huge. So mobility. Would you prefer to be in an office all day, staring at your monitor, working that way, or would you prefer to be able to move around and do different things and take your data with you? Who wants to stay in one place all day long in front of your monitor? Does anybody want to do that? He does. Okay, he's a hardcore coder. That's cool. That's good. I love it. We can geek out after I'm done. But at the end of the day, mobility is getting ridiculously powerful. Now, you put a GPS chip in every mobile device on the planet, and you've got some interesting things going on in terms of where things are occurring, and then you start looking at what is occurring, and you start looking at when things are occurring, and now you start to evolve into why. Yes?
Doesn't spectrum become a huge limiting factor in that?
Yeah.
In that
Yeah.
process?
Spectrum reallocation is a big issue. Most Americans don't understand it. They didn't understand the Telecommunications Act in the first point. They didn't understand the reauthorization. They have no idea how it's being sold off now. It'll have significant implications on all future commerce, not only domestically but internationally. Exactly. There's not enough spectrum to go around, and that's why they're trying to slice it into smaller and more pieces.
That's why we need fiber, because that, you multiplied the spectrum immensely by having those kind of.
There's lots of different, the telco piece is huge. Analytics. So we started a couple years ago to make all of our investments to better understand the analysis we were going to conduct at GCS. So there's standard off-the-shelf packages we use all day. We use a lot of Microsoft technology, a lot of Esri technology, a lot of IBM technology. But where our biggest value was for customers wasn't just figuring out how to use the tools faster than they could read the help menu, by the way. And oh, by the way, we're competing with their own cloud initiatives. We started focusing on algorithms. We started focusing on those processes that were helping us with certain answers. So that's where we're putting all of our money. Then the three A's of big data that I coined and put out there a couple years ago, or about a year ago, I think just as much as the 3 V's is you better understand accessibility, affordability, and agility. So there's a huge issue about how our information is accessible, what's accessible, about the democratization of information, about privacy issues, about how do I get it. So a lot of our clients are always asking us, I just want to access my data. Please, I don't know where it is, how to get it, I just need to access it. So we're constantly working on the accessibility issue. That's probably 80% of all the requirements we do for every project is we just need, we don't know what to do, I need to access it. Affordability, that's becoming even more important. People are absolutely driven more and more, at least from our perspective, by that total cost of ownership and that return on investment. The people that are buying from us are not buying just because we're running around saying big data. That's useless. What they want to know is, how am I going to achieve some type of return on investment, especially for the private sector clients. The government folks, not so much. And then agility. Take everything you know about service-oriented architecture and web services and how we quickly connect and consume and deploy apps, and the people and the organizations that can build apps, applications that have discrete functions that do things, from identifying the problem to answering the problem, they win right now. Now, a lot of those models in mobile application development, agile development, are all centered around what? Can anybody tell me the major driver of all mobile apps today? Gaming, but what's behind the gaming? Advertising. The internet, if you haven't noticed, has become a massive advertising medium, right? Think of the money spent right now by the top 5 companies in this country to basically figure out how to put an ad in front of your cerebral cortex. Guys, it's like $2.5 trillion. Okay, so this isn't about getting smarter on the planet and helping save America and save the whales. What's driving a very large part of our entire GDP in terms of app development and agility is around one thing and one thing only, and that's placing an ad before you. Are we a big producer nation anymore in this country? What are we?
Consumer.
We're a consumer-driven economy. So I really want you to notice people are looking for extreme value and extreme agility and in terms of accessing this information.
That funding, though, everybody else gets to ride on those coattails, though, in a way.
Sort of. Again, I don't want to have the philosophical debate right now. I just want, if you got a technical question, raise your hand. Now I'm going to switch into specific examples of where we started to play around with this phenomenon, big data. So back in 2005 and 2006, GCS got involved in a project to try to help the soldiers in Baghdad. So do you guys remember what was happening at the Battle of Fallujah? Is anybody aware of the amount of death that was occurring for our soldiers in Iraq? So there was a program brought to our attention where a thing called an unmanned aerial system, you've all heard of them now, they're called drones. These are hand-launched, tactical unmanned aerial systems. You'd launch them, you could fly them over a building, you could put a camera over the corner. Now, that was 2006. Does anybody, the amount of money that the American taxpayer spent with us to figure out how to get the video down from the aircraft to the ground station, combine it with a map, and present it to a warfighter, that program was about a $2.6 million program. We worked really hard on it. It was really, really hard. And we had to do a lot of things to make that effective so we could actually try to get eyes on the enemy before they came across the street, right? It was called the Smart Data Project. I could do that entire workflow. I could manage all that video and in 50 cameras, and I could do it for $800 today. Who owns a UAS or a UAV or a drone right now and flying around town? Yeah, I do. I mean, it's unbelievable how quickly there was a convergence between sensor, data network, information, and essentially delivery to the customer. This has blown me away. This is 2006, 2007. And you've all heard about the Predator drone, the H-1B Predator, right? That entire project was not even something that the US government wanted. It was a pilot project of a company called General Atomics. So it's amazing how quickly things are changing when it comes to these data and these systems. And the hard part in this project, as many of you all know, was to take this system and that system and figure out a way to bring that, what we call geospatial intelligence, or GeoInt, down to these laptops in these ruggedized cases, so the guys in Afghanistan and Iraq could have that information so that they didn't have to put the soldiers in the harm's way. And this was the beginning of something that I started to see, which is now being described, of course, as sensor markup language. I don't know if anybody works with SML, or you might hear about predictive markup modeling language. Many people in the room know about the sensor web and this whole idea of everything becoming IP addressable, as in an IP address. So we had the idea that if you could put an IP addressable sensor on board the aircraft, and it was this tiny little weird camera, hook it up to a radio, and broadcast it using MPEG-4, we could actually get the data, and no one said we can do it. We ended up being able to broadcast, back then, MPEG-4 compressed video over 5 miles line of sight. And that we got the data down to the ground, and then we were able to exploit it. So the fun thing there was then to try to match up the workflow of the person to the targets in the video. Then a Marine stood up at a conference I was at, and he said, "That's crap, I don't care, I don't need that. What I need is I need to be able to, when I click the mouse, guns go off." And I was like, okay, that was a slightly intense statement. Major Neutral was his name. And so what the Marine Corps ultimately asked us to do is that if they were watching video anywhere in the world, they wanted to be able to literally click a mouse and target that entity and know the entity's location within 5 meters accuracy. So has anybody ever figured out how to handle latency over an 8,000-mile SATCOM relay with 700 millisecond latency? It's a really hard problem. Today, those problems are less and less hard. We've solved a lot more. But ultimately, the scaling of this became ridiculous, because where DARPA and other people wanted to go wasn't just one autonomous hand-launched UAS. They were talking about swarms of these things. Swarms. So if you go and look at YouTube video now, and you look at Carnegie Mellon, and you look at MIT, and you look at Stanford, and you look at the top engineering labs, MSU, whatever, you look at the top engineering schools, you will see outcomes now of hundreds of millions of dollars invested in the algorithms that are essentially finding a way to automate and orchestrate hundreds of these autonomous devices into a dance, into an orchestrated way. And you can go look at it. It's quite amazing. Did anybody watch 60 Minutes and you can see what happens when you throw an object at one of these drones? It immediately can receive and reject. That's big data on demand, and it's happening. So it's quite remarkable what's going on. Now, let me give you another example real quick. This is the work of S&K Technologies and a company we started called Adelos. This is the latest picture of the latest unit. This is the laser center, and these are electrical optics. Those boxes, which are about that wide by about that deep, when we started the project about 7 years ago, was the size of these two tables put together. So we've condensed and made smaller and smaller and smaller. that one laser shoots a light down 8 kilometers of fiber. And that light and that fiber is so sensitive that when I talk or you walk or a plane flies by or a car drives by, it actually reacts to that pressure. It's so sensitive it picks up those pressure variations. And we, in a short, very, very sweet way, we convert those pressure signals in light to sound. We convert pressure to sound using light. And it's the only one of its kind in the world. We compete with 3 other companies in the space. It's manufactured by S&K Electronics, S&K Technologies. They own the company now. I still consult to them. And the amount of data this produces, at the end of the day, when we did our last significant field test on April 26, 2011, at a facility that cannot be disclosed, we hooked up that system. This is what we called Banshee. This is our special IBM box. This is the first generation IBM Blade Center with InfiniBand connectors. We hooked that up to 5 fiber optic lines, all about 2 to 3 miles in length, representing approximately 4,000 individual sensor zones, 4,000 individual sensors, and we recorded for 24 hours 27 petabytes of data. 27 petabytes in 2011. So that's why we won some awards. You've read about it in the paper. That was novel. The next question is, what the hell do we do with all of it? So we worked with IBM, we worked with some other folks, and we used a technology called streams, and we began to develop a way of analyzing all that as it came by. So the concept here is this. It's quite possible, so I've got sensors everywhere, and we're listening to everything. It's kind of a vacuum cleaner approach. And I can bring it all, and I can try to put it into a storage device. Who was talking earlier about the problem of storage? How much storage do I need if I'm collecting 27 petabytes a day? It's a lot of storage. So a lot of people that are in this game of figuring out what you need versus what you don't need, keep only what's important, throw away the rest, we started shifting from collect it all, store it, and analyze it later, which doesn't work in this particular instance, to collect it all, but analyze it as it's moving by. So I'm literally looking down into the data streams, and I'm running my analytics in the data in motion versus the data at rest. Here the data isn't moving. Here the data is moving, and it's moving pretty fast. You know, gigabit Ethernet speeds, 10 gigabit Ethernet speeds, 100 gigabit Ethernet speeds, okay? And it's moving very fast, and I've got to analyze it because, as I've written about and talked about, an example of what we were looking for there is if you walk into a room in a party, and let's say there's 100 people in the party, right? It's like, rah, 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 you got the cacophony of the action. We were literally trying to separate out that one conversation from the 100 individual voices, and we were trying to find every time they said the word zebra within all that noise. And that takes a lot of analytics. So we learned a lot of things, and based on that, we suggested, and the university began teaching this. There are more people at the undergraduate level who have taken advanced streams classes at the University of Montana than anywhere else in the world. Period. And that didn't take a whole lot to get done. I mean, I had to beg Eric to teach the class, and I think I funded part of the class, but at the end of the day, Missoula, if nothing else, should be proud of that fact. It's not the only fact, but it is a fact. And what that means, guys, when you're talking about Big Data Week and Big Data this and Big Data that, we are building and can build an industry here in this town that is incredibly unique. And that's simply because myself and Five Guys and Fries and SKT and SKE and tribal investment and US government investment, we built a sensor system. Now, as I told you, where is that going? Can anybody give me a guess where something like this is going to go?
Prisons.
What? Prisons? No, no. Well, that's actually a really good answer, but I can't talk about that. Can anybody, if we were doing 27 petabytes in 2011 on a good day, where are we going next?
Border security.
Yeah, but no, I don't want you to think about the application. I want you to give me the tech. What is big data about that? That was 2011, it's 2014. Where's the next space you would go in terms of managing that data? Handling it. What? Internet. Yeah, the internet's key. We're definitely dealing with an IP6 problem, Internet Protocol 6. All I'm saying is that when you have that much, even if you're siphoning off only gigabytes per day based on what you actually are listening for, we're now getting into holographic storage, and we're getting into new mediums of communicating that information because the existing methodologies no longer work. The telecommunications providers don't have it. We don't have enough microwaves to burst it. So when I was talking earlier about metadata, this is where it becomes important. So we got so big with this one sensor, and we're just one sensor. There's a lot more complicated, more advanced sensors out there. We got so big we had to get small. So we've reached the zenith of wow, and we have to now start to break it down into small. And what I mean by that is we're now dealing with metadata analytics. We now have to start abstracting the information that we're getting, and we had to create a symbology. So we have created an abstraction, a symbolic layer. It's a metadata layer. And we are working now to do analytics on a symbolic abstraction of what ultimately is an optical physics principle based on pressure that is converted in the world. And that's what's getting exciting about big data, is it's making us push for new innovation when it comes to technologies. And those things can be invented here, guys. They don't have to, we don't have to have some big fancy place. This again is the visualization of that. Here's some signal processing and visualization down here. Here's a map. By the way, the first time we hooked up this thing to Windows, which we loved, we threw 20,000 messages a second at Windows and it literally blew up. I shut down the entire server. That was a $200,000 day, and it was a bad day. My client was not happy, and we'll see what happens. Retail. That was the one I forgot to mention in my introduction. I'm going to give you a retail example. Super excited about this. Who's involved in retail here? Anybody? Okay, yep, retail sales. So we had a client come to us. Let me go back here. And the client's called Washington Survey and Rating Bureau. We're really proud of these guys. We love this client. These are basically pathways for tsunamis that may or may not occur in Puget Sound. They're a big risk insurance company. So they provide risk calculation scores and sell them to State Farm, PEMCO, Allstate, whatever. There's guys that sit around and figure out what risk is associated with commercial property, right? And that's how your homeowner policy is set, or your commercial policy is set. So we helped them with all their algorithms, and we started to look at this relationship between all these places and all these locations, these red dots, and risk. And that led us to another idea last year, and we did a webinar on this. I don't think anybody watched it. And we invented a thing called social Doppler at GCS, which is what we're coining geomarketing. Geomarketing is not new, but in some ways the methods and techniques today in big data allow us to do things that were hard to do 2-3 years ago. So what we did is we looked at the Los Angeles basin. First thing is we said, well, let's get the biggest area with as many people as we can get our hands on, and it's close to us, so it was LA. We then harvested, using the Twitter API, 900,000 tweets in 24 hours. These are geolocated tweets. So anybody tweeting here? Okay, a few of you, you know how you can turn on your location or not, and you can let people know where you are or not. Well, believe it or not, out of 18 million people in the LA basin, 900,000 on average a day let you know where they are. Okay, so that's the way that is. So we sucked all that down. Next thing is we geocoded. Eric, would you like to tell people what geocoding means?
I'll leave that to you.
Oh.
It'd be on the spot.
Okay, well, I was turning to my excellent esteemed professor of GIS. Basically, we put those points on a map. So we geocoded it. We took those latitude and longitude coordinates and we placed it on a map. That's 900,000 a day, so that's not that hard to do. We then did a hard thing. We looked at what people were texting, and we looked at what people were saying in their tweets. It wasn't just texting, but the text in their tweet. Has anybody looked at that stuff lately? I mean, it's ridiculous. And there's a whole new hieroglyphics, a whole new symbology that doesn't meet any dictionary. There's no way to look it up. So we had to start coming up with ways of creating a learning algorithm that would understand the context of when people do LOL, blah, 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 da-da-da-da, hashtag, hashtag, you know, whatever, because standard things don't understand anything about that. So we created what we called a mood analytics scale. So we were really trying to measure mood, okay, and not sentiment, but mood. And we basically came up with a very arbitrary 0, 1, 0, -1 for a mood scale. And what we did is we did our best to try to take the text that was in these tweets and assign it a mood ranking or a mood score. So it was a scoring algorithm based on a word bag association algorithm we took. A lot of text, a lot of data. Then what we did is, based on the mood value combined with the geocoding value, we created a clustering algorithm. We grabbed a clustering algorithm, it was out there, it was open source. We didn't need to invent the clustering algorithm. We just took a clustering algorithm that existed, and we started to put this stuff into lumps. So instead of points, we started to try to aggregate them statistically based on geostatistical principles and how they can normally be organized in a cluster. Then we color-coded and thematized it. So we started to say, well, if I'm happy, should I be red or green? Well, happy is green and red is sad and mad. So we put some color on it, thematized it. We started to come up with some chloroplethic techniques. We started creating polygons of mood, right? Then we did continuous correlation. So we looked at where these clusters were, and we started to think, wow, why are so many people supposedly unhappy based on our ranking, our mood here? And we started to see associations with parts of Los Angeles. We started to see happy associations with people at certain stores. We started to see interesting correlations based on socioeconomic demographic trends. We started to see really interesting scalar options with people coming in and out of 7-Elevens and tweeting about things. And you get the drift. This is called correlative analytics, and it's really powerful. And if you listen to Dan Wagner's stuff, he gave you some really world-class, multi-billion-dollar examples of correlation. Because if you start correlating down and then longitudinally across these data sets and start to look at them that way, really interesting things start to appear. We've only scratched the tip of the iceberg, and then we created a polygonal display, and we figured out how to turn this into an advertising engine. So we have a client in Los Angeles that buys the data from this system, and they use it to send advertisements to people on their mobile phones. And we figured out how to connect to 10 million mobile phones. We do it all out of our server, and maybe one of the reasons I needed a bigger pipe is I got milliseconds matter in terms of my client. I can't sit here and do this on slow pipes. My company has to leave Missoula. So we figured out how to not leave Missoula, get a better pipe to downtown Seattle so that I can co-locate there with a tier 1 provider and send those analytics down to stores in Los Angeles that are doing this analytics all the time, 24 hours a day, 7 days a week. So here's the scenario. I'm sitting here and I'm a store here, and I want to buy the data from GCS data service. Here are my concentric circles, and here is a consumer that has a mobile phone that is tweeting, and the tweeting, we analyze all of that. We know what polygon they're in, what mood they're in, and they have the app loaded on their phone that allows them to get advertisements from the top retail stores they're interested in. And so when they get to this location, we know it, we send an ad, and that ad has a text, and that text gives you the route to the store, the sale to the store, and says, if you get here in 30 minutes, we'll give you 40% off that shirt. Do you think it's working? This is like crack for consumers. It's very powerful, because we're combining gamification with a whole bunch of mumbo jumbo that no one understands, with some techniques to get the right ad to the right person at the right time, only because of big data analytics. And we're doing that on a single blade server in our office in Missoula. Okay? So what this ends up looking like is this, and this is why we call it social Doppler. You do a time series on this, and you actually let this wash over the LA basin, and it looks exactly like NextRad weather radar. You know what I'm talking about? Anybody a weather junkie in here? I am. I sit there and watch that stuff all the time. I love it. I mean, I wish I was in Nebraska right now chasing storms, but I'm not. And so we can create store locations, and we used Esri COTS for the display and some of the analytics. We used a whole bunch of other stuff to do it, but it's amazing what happens when you start to look at human geography, human tendency, and you really start to look at psychology of these things. Okay, so that's a good example of retail. Now, health, and I'll close out here. We had a client at GCS called the Institute for Health Metrics and Evaluation. Anybody ever heard of them? Probably not. Funded by the Gates Foundation. Their whole job by Gates was to figure out if you could determine the efficacy of international trade and international aid on affecting healthcare improvement around the world. So if I'm United States and I give $100 million to Botswana, have I actually improved the rate of malarial infection in Botswana, as an example? By the way, we give billions and billions of dollars all over the time from donor nations to receiving nations, but no one apparently ever really measures the outcome of all this aid. We run around waving our hands, but you know, they don't even have an accurate census of the number of people in Botswana. So if you actually look at census demographics and population statistics, ask yourself, do we really have an accurate count of how many people there are on the planet? Realize that's all an estimate, right? That's all a model. So no one really ever counted 7.2 billion people, just FYI. So we looked at that, and it was a really hard problem. They needed time series, so we started looking at these connections and all these other things. Well, as a good geographer, I realized that there was a lot of information, of course, in this data that we could start to mine and harvest and figure out a way to productize and commoditize and sell. And recently, we at GCS have been starting to play around with this notion. Population healthcare dynamics is a huge mega trend right now in the healthcare system. Healthcare is being transformed as we speak. We started, just similar to what you were seeing in the retail example, we started to look at synthetic interdisciplinary relationships between different stovepipes or different areas of endeavor and analysis. So of course you have electronic medical records. That's a huge mega trend occurring in our healthcare system. By the way, up until about 3 or 4 years ago, all your medical records were stored as?
Paper.
Paper. Okay, and over here we've got genetics and genomics and protogenomics. By the way, I think we had a presentation on genomics and big data at the University of Montana, which is huge. Take genomics and multiply that by 20, and you've got protogenomics and protogenomic mapping. By the way, the goal there is what? You walk in, you get your genetic profile done, you get your protein sequence done, and they manufacture the drug on demand for you. I don't know if anybody watched 60 Minutes a few weeks ago. Doctor got up and said, oh, by the way, all our trials have been on men and we've been giving all these drugs to women. We have no idea how they work on them. Cool. Advances in medical science. Then we combine that with what we love, zip code. So you take the zip code, where something is, the gene code, which is essentially our euphemism for genetics, genetic information, which is mostly unstructured, by the way, and we take the barcode and we're mashing those together into a thing we call GeoLife. We're developing an API, and what we're really trying to do is bring these 3 disparate sources of data together into one unifying fusion, and we're using social media because what we're learning, if I take that same retail example for LA Basin and I start to look at what you're buying, what your eating habits are, I can predict accurately what the rates of diabetes will be for an area. This is not new, other companies are doing it. But think of the implications of that. Think of the implications coming very, very soon. Well, you'll be handed a carrot by your insurance provider. And they will say, if you allow us to monitor your heart rate and your blood pressure and through remote devices on your clothing and on your things, we will incentivize you by a reduction of your rate if you walk a mile a day, eat less sugar, do this, do that. So you'd want to talk about a brave new world. Get ready. Microsoft is developing technology and someone else to have wearable sensors in your clothes. And these things are now available. If you had a chance, if your insurance provider said, we'll reduce your rates by 20% if you eat this and do this, would any of you consider taking that reduction in rate based on behavior modification? I would. Hell yes. When I went to get my insurance policy and I was still chewing tobacco at the time, they said, if you stop chewing tobacco, we will reduce your rates by this, and I quit and I saved money. So that's all coming. So you can take the same thing we were doing in consumer retail and shift it over into the healthcare area, and you'll see what that's happening. And by the way, we are working with IBM on this. So what we're doing is we're now saying, okay, it's not about advertising to the consumer to get them to buy something based on advertising stuff. We're actually trying to look at these, and we created, instead of a mood scoring table, we came up with a healthcare table, basically dealing with different rates of healthcare based on population, your age, your weight, and any other data we can get. And you're starting to see these really interesting correlations between behavior, as Dan Wagner said. People that vote a certain time of the year in a certain way are often very good indicators of whether or not you're going to have a good driving record. So they're starting to take DMV databases and combine them with your voter record databases, combine with your credit card transactions, combine with your browsing history. And you guys have all seen this now. You can create an incredibly accurate individual profile of the individual. And that becomes very powerful in terms of big data. I'm not here to argue if that's a good thing or a bad thing. I'm just sharing that as an example. So what I'm excited to announce is that IBM, who we work with as a business partner, has a technology called Watson. Many of you may have heard about it in terms of the Jeopardy game, incredible natural language processing engine. We held the first Watson workshop in the world here in Missoula about 2 months ago. Very quietly, no fanfare, nothing. It was a private entity, private event. But IBM, which is an interesting company, chose Missoula as the place to conduct the first Watson technical workshop on what they're bringing out, and they have been unveiling it for about the last 2 years. Big announcement in New York in January. So what we'll be doing as a company is we're going to be bringing the Watson technology to bear on our analytical framework so we can deliver these forecasts and predictions. And that that project for us is called Noesis, which is the Greek word for, anybody know their Greek? Greek word of the day? Noesis. That means understanding. So we're bringing cognitive computing combined with real-time and visualization. That real-time spatial temporal is what I was showing you with that social Doppler. So sometimes we build things at GCS and we don't know where they're going. We don't know, remember, we're technologists and we have no idea what we're doing. We build it over there and then all of a sudden we go, wow, there's something over there, and we try to do it over there. The dance is to try to do the research but also try to figure out how to turn it into revenue every once in a while. And there's an algorithm that we have. This is about all I want to share, but the algorithm allows us to translate in real time actual text that you would understand and read to a spatial function. So we figured out a geometric textual transform. It's called the STS algorithm. I unveiled that at a world conference a couple weeks ago in Tampa. No one understood what I was talking about, but that's a good idea. And what we're able to do is make elements of this ungodly amount of natural language that is all georeferenceable. We're able to make that small, and then we're able to take some of that symbology I was talking about earlier, that symbolic language. We're actually able to code intent into the data by manipulating the symbology and turn that into data that's autonomous. So the data now is not network dependent, it's not database dependent, it's not relational dependent, it's not associated dependent. It actually can go find you based on your profile. So we've created a data set that is a bot that is programmable based on symbolic language that can go find you based on what you need. So that's the way you get around searching for something. The data ends up having autonomy once it's created. That's the big insight that I'm trying to share with you guys, and you're the first to hear it for what it's worth. And at the end of the day, this allows us to do what we do as geographers, which is why we started GCS, and that's to really start to look at these correlations, these relationships. These are layers. This is what GIS was designed to do. Now, I'm not suggesting in any way, shape, or form that GIS is big data or big data is GIS. But I am suggesting it is a method and a technique in an area of science that we try to apply. So every time we look at a problem, big or small at GCS, we're always asking first and foremost where, and then we're asking what, and then we're asking when. And by the way, you combine space and time, and you actually have a lot of the equation figured out. And then if you try to figure out what something is, then you're able to get into understanding why. I'm super excited and hyped on Internet of Things. So I would suggest everybody leave here tonight and go Google Internet of Things, Internet of Everything. I wrote an article on it. It's right here. You can read it. One of many articles written. Had a chance to interact with the CTO of Cisco, got a quote from her. The implications here, 50 billion things on the net by 2020. 50 billion things, and some people think that's conservative. The car, phone, house atmosphere. Projects are being done right now where the refrigerator knows what the milk level is. The refrigerator can talk through your Wi-Fi network to your app, to your phone, and when you walk in the store, it'll auto-populate what you need to buy. You can go scan the milk carton, get all that indexed, and literally leave the store without ever going through a cash register, all using various techniques. Now, I think Joel Henry showed a good video the other night of an example of that, except he used retail. The one we're working on with IBM and Cisco is the future store of tomorrow. Matt has been looking at ways of taking the technobabble and actually turning into something I understand. But IP6 is huge, and you got to think about it. So I wrote an article on that, and then I just wrote an article on the future of cognitive computing, which was also published in IBM's Data magazine. Those are things you could read if you want. You don't obviously have to. And that's the end of my presentation. So I'd be happy to take additional questions or comments or discussion at this time about anything I've shared. Okay. Thank you. Thanks very much. I guess what I'll leave you with is this. I tried to provide you with an example of what I think big data means in terms of the retail, which I forgot to mention at the beginning. I shared with you an example of defense or security, and then I shared with you an area that I'm really excited about, which is healthcare. There's so much need. So those are the examples. I tried to give you some idea of the methods and techniques we're using associated with those challenges. And I provided you a brief overview of what big data is, and then I showed with you where I think this is going, which is some very troubling questions we have in terms of energy, in terms of consumption, in terms of human processes and procedures, and really a whole host of ethical and constitutional implications. But those are for other nights. But again, I thank everybody. Any other comments or questions of anything? Yes, sir.
Many.
Okay.
Great conference. So, for your retail example, how do you send advertising? Do you tweet back to the user? Do you do some kind of remarketing? Or?
So what we built is we built an app that basically lives on Android that you install on your phone. So there's a hard way to get the message back to the phone, and there's an easy way to get back to the phone. So let's say you're a consumer and you want to be able to get advertisements from Sears and iMagnin and Kentucky Fried Chicken and the Surf Shop. You download the app and it becomes a one-stop advertising portal for you. So the easiest way for us to get the ad back or the message back is we text to that MAC ID based on the location of the phone, based on an install that goes into the Google application layer. And by the way, we can ride right in on any other app that is already installed, and we may or may not be negotiating with certain device makers to have that pre-embedded on the phone as a great way of automatically advertising. So that's the short version of how we get the ad to.
But I gotta have the app in order.
The easiest way, yes, it would be good for you to have the app, or you would already come pre-embedded on your phone as part of the OS.
Okay.
How are you incentivizing downloads of that app?
We are incentivizing the downloads of the app because the people that buy the data services from us and the app from us are the ones that are basically providing that app to their consumers, and the consumers are downloading them so they can get the advertising communication from the stores.
So is it like a loyalty type program?
Yeah, it's loyalty. It's also, hey, I want the app because I now know wherever I am within proximity to these stores, I might get an advertising special that'll give me a sale. So it's really about making sure that you know when the sale is or the promotion and everything else like that.
So how do you get them hooked on that crack?
How do you get them hooked on the crack?
The question is, how do you incentivize the initial download? Once it's downloaded, it sounds like a fantastic.
Yeah, well, what I often do is I might want to know what Eddie Bowers are doing. So it's really up to the companies that are buying our service and our app. They're the ones advertising it and promoting it. So when you walk into the store, they've got ads and they've got brochures, download our app.
If you walk into a store, you see a QR code by the door.
Exactly.
Again, it's down. Okay.
Yeah, and we're not, just to be clear, we're not worrying about that side of the equation. I know you are, and that's good. We're just trying to figure out how to get all those mechanics working so that total data flow goes. Because we're not good with commercial retail and advertising and understanding our clients. That's not our business. Our business was just making sure that all that data could come together. And right now it's in beta test. So this is being beta tested right now in a part of the country which may or may not be the LA basin. Good questions though, excellent questions.
When I lived in Singapore, and Singtel owns all three of the data providers there. They own M3, Singtel, and the other one I can't remember, right, StarHub. And they would push these things to your phone as a carrier via SMS because the carriers were actually signing up with the retail industry. So when you walked in to a mall, the location tracker said you walked into the mall and Singtel was cutting advertising deals with every store in that mall, and you didn't have to download the app. It was being forced onto your phone. And Singapore is all retail, it's all consumer driven, and that was helping to drive the economy through the carriers.
Yeah, and part of, I guess, a part of that example is that we kind of backed off from some pretty fuzzy logic that we had created to determine mood. I mean, that was an experiment. It was funded by an agency that wants to know about mood and crowd, and it was actually an algorithm that was used to diffuse a population from getting together. You've heard of the Arab Spring. You know, sometimes you can send a message to this phone and then they get the wrong message and they go left when everybody else goes right. So it's a diffusement technique, maybe. We kind of went away from that because that's really hard to sell. So we just kind of broke it down to brass tacks. I want more Kentucky Fried Chicken. You get the drift. But great comments. Other people had a few other questions or comments. I want to make sure. Yes?
What is the human role in analysis of big data?
That's a great question. Excellent question. Huge debate right now about machine to machine, machine to human. Where is the human in the loop? Is the human in the loop? And if so, where and why? And what is that role? So right now, a lot of work is being done on next generation human interface. So Google Glasses has now come up. It's commercial. It's available. You can buy it. That was not new, but Google figured out how to make it there. So that's a whole new way of looking at human-machine augmentation and interaction. I would look at augmented reality, AR, as the hottest thing going on right now. We built a webinar on that. We walked around Missoula and did augmented reality and showed you how we could present a menu. The other thing is that increasingly in these systems, there's so much so fast that it's becoming very, very hard to understand where the human is in the loop, what the decision-making process is. That's what's really kind of scary about some of these things right now. More automation, more to machine, M to M is what it's called. You have to have moments of intervention. You have to have moments of clarity. An interesting story, and I don't know if this is true or not, and I have no way of verifying it, but I did hear back in 2007 that for the first time in US history, we actually had a full, complete autonomous kill. And what I mean by a full, complete autonomous kill is that there was a machine that identified a target, that talked to another system, that launched a weapon system that ended up eventually killing an individual in a theater of war, in an act of war. That's a really remarkable thing if it actually happened, a complete autonomous kill. Now that's a little bit urban legend, urban myth, but you've raised a great question. So here's what the cutting edge is. The cutting edge is now coming full circle to visualization. It's coming full circle into next generation systems for what's called human wetware. So just when you get done exhausting the optic nerve, right? Because we learn mostly and learn a lot through the eye. People are actually back to Neuromancer. I don't know if you've ever read any cyberpunk or any of the future science technology from 25 years ago. People are actually designing right now at labs and actually have full-blown mock-ups. You can actually jack into systems and have communication between your brain and computers. Now that was a little sketchy 5, 6, 7 years ago when I would talk about this. 15 years ago, people were like, oh my God, wetware. It's absolutely happening right now. And so you're seeing that in our movies. I don't know if you saw Johnny Depp's new movie where he's Transcendence or whatever it's called, or Decadence, or he becomes a machine and they download his conscious in the computer and then he figures out how to control nanobots and you know what I mean? The reason Hollywood's starting to hype that is because they can sell tickets, because in our psyche we now know that we're in some really interesting areas that are causing tension in our psyche. And that's the notion of the mem, or the notion of the zeitgeist. And I could talk to you all night about the question. It's a great question. We don't have it figured out. I will tell you this. A lot of the things I showed you early on about these visualization presentations and buttons and clicks and things, that's becoming increasingly antiquated and outmoded. In fact, it's causing us, whether we like it or not, which I don't like, to reinvent ourselves all the time to figure out new ways in which we are going to try to keep the human in the loop in terms of big data. So, great question. I don't mean to keep you guys any longer than necessary. If there's one more question, I'll take it and then we can bail. It's late, I know. Computer science, yeah, you had another question? Let me do computer science guy, since you asked. Yeah, go.
A quick comment. You mentioned the metadata, and I remember hearing about a couple months ago, Edward Snowden, the huge NSA whistleblower guy,
Yep.
did this seminar about how we should still be worried about this spying or whatever, because even though they have a bunch of this data, this metadata is still usable. And that's kind of what you went over there, saying metadata making this large data back into the small thing again.
Yeah. Yeah, I just think my point is that for those of us that grew up in the GIS industry, we didn't build it, well, we built data sets all the time without telling how we created it, what we created it with, or what the accuracy was. So then there were standards that were developed for documentation of it. It's very rich, and it lives as an XML format now. It used to be really, really hard. And I think you'll see more and more of that. And let me put it this way, and this lecture was not about privacy, it was about big data, but the implications are significant. And all I can say is other lecturers have talked about all week is everybody has a unique digital trail. You have a digital ghost in the system, and it's managed, controlled, manipulated all day long. And by the way, you ought not to worry so much about your government. You ought to worry about things you've never heard of, which, by the way, aren't the US government in this instance. So you have a digital trail, you have a signature, and it continues to grow to the extent that we move more and more into digital world, and we grow more and more ways of collecting it, more and more ways of analyzing it, more and more ways of correlate. A lot of the stuff I showed you was limited effort over courses of a few weeks by GCS in Missoula. And I guarantee you there's lots of other companies that are a lot smarter and doing a lot of interesting things. So the interesting piece here is to start thinking creatively about where this is going, and I would argue, what role do you want to play in it? Because I don't think the world's going to stop tomorrow because of big data. I think we have to figure out ethically, legally, spiritually, otherwise, what are we going to do and what does this mean, right? It's the same old thing. But great question. Okay, guys, I think I'll let everybody go. Thanks again for your time and attention. Appreciate it. Oh, and for those of you who want to, I've got 3 books up here on big data. If anybody wants a copy, these are free. You can grab them on your way out.